Hello everyone. Today we are going to talk about a sophisticated but in some ways still brand new technology, the augmented reality technologies. Because of the prosperous development of network chips and convenient wearable devices, the AR technologies has come into people's life and benefit us in many different fields. So let us bring you into a real world with fantasy. First of all, let me introduce the process of how the engineers apply the technology. As you can see, we will use a wearable devices such as head-mounted displays as an input devices to collect the information of the real world. Then the real contents will be sent to the processor server requesting the virtual objects generated by the software. The server will send the virtual objects to the processor, which is able to use different ways to display the results. According to this process, we would first introduce the display technologies would be used. Firstly, let's see the optical see-through display. It works by placing optical combiners in front of the user's eyes. These combiners are partially transmissive, so that the user can look directly through them to see the real world. The combiners are also partially refractive, so that the user can see virtual image as well, bounce off the combiners. Secondly, take a look at the video see-through display. In many cases, the video camera is attached on the back of the displays, facing towards the real-world scenes, which the user is looking at when watching the display. These types of display create the digital illusions of seeing the real world through the displays. Hence, they are called video see-through displays. Thirdly, a projection-based technology can display virtual image directly on real object surface. It requires a physical surface where the images can be projected onto. Here's the examples.
Now we will point out the advantages of AR systems and talk about different AR hardware form factors and technologies what they are used. At first, it's helpful to provide operators with immersion by AR hardware. Not only that, AR systems also are useful on enhancing the collaboration among multiple users. There are mainly three different categories to be introduced. These are wearable devices, handheld devices, and projectors. On the wearable devices, multiple wearable augmented reality technologies are used, which are useful to improve the AR experience while maintaining an easy-to-carry style. For example, AR glasses use optical see-through display technology, which means that real-world information is remained, but the downside is that it's sensitive to light source. Head-mounted displays use VST or hybrid display technology. It brings more sense of immersion but less mobility. A trading technology is retinal scanning displays technology that use laser to draw virtual images directly on the user's retina. Virtual quality is great while maintaining low power consumption, but the technology is far from nature now and requires more time for development. However, it has great potentials in the future.
Smartphones and tablets are very common, and it is a great starting point to experience AR. It's not powerful, but it is easy to carry thanks to its power efficiency. These devices use video see-through display technology where the environment are digitized. Pokemon Go is a great application where the environment is analyzed and displayed on the screen with virtual objects. It has great image quality, but the downside is that there exists a delay for the content to be updated on screen. Last but not least is the projected device. They are placed within the environment instead of carried by the user. The quality of the image is greatly affected by other light source. Hence, this type of display requires an indoor scenario where the light source is controllable for the best quality. The device also needs to be calibrated for different environment. But projection technology has the benefit of utilizing full computational power, and they can deliver content to a group of people at the same time, which might be ideal or crucial for some scenarios.
Now let's look at some of the tracking systems adopted in augmented reality. In the magnetic tracking system, it requires a transmitter and one or more receivers to work together. Transmitter emits magnetic field and the receiver is responsible for detecting such field. Since the receiver is attached to the objects that are being tracked, the pose of the object in relation to the transmitter can be measured by calculating the orientation and polarization of the detected field. However, the magnetic field fades out quickly as the distance increases. The system is also affected by other magnetic material in the environment. Moving on to vision tracking. Vision tracking can be categorized into fiducial tracking and natural feature tracking. Fiducial tracking can be referred as the marker-based tracking. As you can see from the picture, the camera firstly searches the marker, then identifies its 3D position. At this stage, 3D virtual object can be mapped to the marker and shown on the display. In the natural feature tracking, features are extracted from the natural environment. Therefore, it's often called markerless tracking. Features can be edges, surface texture, or interest points. There are advantages and disadvantages of each. Marker-based tracking does not require database. The existence of the marker makes the tracking very efficient. However, in such system, marker is a must and has to be shown fully in the view. In markerless tracking, features can be easily extracted as they are everywhere. Features even work when they are partially shown in the view. However, it requires database to store all the feature information.
Let's move on to the interior tracking system. This technology applies the interior measurement unit to collect the information about the relative orientation and the velocity of the real object. The common sensors can be gyroscopes and accelerometers. As the data collection is independent of the out environment, this tracking method can get rid of the limitations from the light. However, as the motion might be changed rapidly, the drift might be huge due to the update rate. The helmet of the fighter pilot applies it. The computer collects the data from the plane and displays the route information, such as speed, altitude, and horizon angle. GPS tracking technology is based on the satellite and widely used in many fields such as military, mapping, and gaming. It is easy to be applied because of the popularity. However, it might be affected by some obstacles, such as channel, so that it usually works with other trackers. There are many hybrid tracking systems, and we just introduced two of them. The GPS can be combined with the vision tracking. It can improve the accuracy as the features of the real objects can be distinguished by the computer vision. And if the GPS combines with the interior tracking system, it can expand the AR use range. For example, the AR can still work in the tunnel under this hybrid tracking system. In summary, each individual system has its limitations, and combining several trackers' advantages can provide more reliable and better performance. Besides, as more trackers are supported by devices, hybrid tracking technology might be the future direction.
Now, I will introduce the mobile AR networking. There are three major wireless network types used in MAR system. V1 is currently the most popular solution in a wide public area. There are two major functionalities. One is to determine objects' location and orientation based on GPS sensors. Another one is the use of mobile cameras and recognition techniques to capture the views. Wi-Fi is the most popular wireless technology implemented in VLAN. It's usually deployed in a local area such as homes and official buildings. The development of Wi-Fi standards is constantly increasing in the recent years and enhance speeds to improve user experience. Well, there are three techniques used in VPN and designed for short-range individual communications. Bluetooth and Zigbee are always applied for location tracking and data collection, while UWB for precision locating and tracking, and the development of MAR system can be divided into three stages. Stage 1 is 2D AR with local image and text overlay, and the connectivity requirement is 20 megabits per second and 15 millisecond latency. Stage 2 requires streaming to 50 megabits per second and 20 millisecond latency to support 3D AR with uploaded image and cloud-based multimedia response. And in the future, Stage 3, Cloud MMR with cloud-based image re-rendering requires 5G streaming to 100 Mbps to 9.4 gigabits per second and only 2 to 10 millisecond latency. In conclusion, the direction of network requirements is high capability, low latency, and offers a consistent user experience.
Overall, today we have talked about display, hardware, some of the tracking system, as well as the networking of the AR technology we use. That's all we'd like to share. Thanks for watching.